Next question. Prove that the opposite sides of a quadrilateral circumscribing a circle subtend supplementary angles at the center of the circle. Have you understood the question? I will explain that. We have a circle and a quadrilateral. A quadrilateral circumscribing a circle. What does it mean? I will show you. Let us draw a picture. We have a circle and let this point be the center of the circle. There is a quadrilateral whose sides are touching the circle. There is a quadrilateral whose sides are touching the circle. In this case, we say that the quadrilateral is circumscribing the circle. So, understood the meaning of the circumscribing? Circumscribing circle means the sides are touching the circle. Okay? Please remember the term circumscribing. Okay. Let me join the center and vertices of the quadrilateral. Let me join the center and vertices of the quadrilateral. Okay. Let me mark the vertices. A, B, C, D. What is our question? Our question is the sum of this angle and this angle will be 180. You can see that AB and CD are the opposite sides, right? The angles subtended by the opposite sides at the center are supplementary. Means the angle, the side AB subtend this angle at the center and the side CD subtend this angle at the center. We have to prove that the sum of these two angles is 180 degree. Supplementary means the sum of this angle will be 180. In the same way, there are other pairs. This angle BC, clear, BC subtend this angle at the center and also AD subtend this angle at the center. The sum of these two angles also 180 degree. We have to prove it. So how to prove this? I will explain. So the question is clear. And remember this BD, okay, this BD may not be in a straight line, okay. I mean the BD, the line segment BD may not be passing through the center. If you join B and D, it may not passing through the center, okay. So you must draw the picture carefully. So how to prove it? In order to prove this statement, let me draw the perpendicular from the center to each sides. Let me draw perpendiculars from the center to each sides. I mean, let me join the center and the point of contact. Can you see AB touching the circle at this point, right? This point is said to be point of contact. Let me join center and point of contact. I get this line. This is actually radius, right? And here there is a point of contact. This point is a point of contact. Let me join the center and this point of contact. Here there is another point of contact. Join with the center. And the last point of contact is this. Join with the center. Let us give some name for this points. Point of contact. Let it be P, Q, R, S. Okay. So let us assume let us make an assumption that let this angle be, let us make some assumption, this angle be A. We have no idea. Let us assume this angle is A, then the adjacent angle is also A. If this angle is A, I can say that this angle is also A. What is the reason? The reason we have studied. Why? Because D, you can see that D is an external point, correct? D is an external point. From this external point, I have drawn tangents dr and ds. From external point D, I have drawn tangents dr and ds. Understood? So once I have drawn the tangents from D, I got two triangles, two right angle triangles. They are congruent. We studied. We have already studied. This is 90 degree. This is 90 degree. We got two congruent right angle triangles. When we get the two congruent right angle triangles from an external point, we have drawn two tangents dr and ds. They're joining the point of contact. We get two congruent right angle triangles. We need not prove that these two are congruent. Please memorize that. So these two are congruent triangles. So their corresponding parts are equal. So if you assume that this angle is A, this angle is also A, because these two triangles are congruent. Clear? I will write all these steps. Before that, let us mark the angles first. And also, from C, I have drawn tangents CR and CQ. Is that correct? From C, I have drawn tangents CR and CQ. Hence, I got two right angle triangles here. Here there is one right angle triangle. Here there is another right angle triangle. Once we draw tangents from C, CR and CQ, we get two right angle triangles here. So their corresponding angles will be equal. Let me make an assumption that this angle is B, then this angle is also B, because these two triangles, right angle triangles, are congruent. And in the same manner, I have drawn tangents from B, BQ and BP. Understood? BP and BQ are the two tangents drawn from B. You know that this is right angle triangle, this is also right angle triangle. I got two right angle triangles. Understood? This one and this one. Two tangents are drawn, hence we get two right angle triangles. These two are congruent. So if I make an assumption that this angle is C, this angle is also C. Corresponding parts. Similarly, two more angles are remaining. In the same way, I have drawn tangents AP and AS. I have drawn tangents AP and AS. Hence, I got two right angle triangles. Clear? Here, this is 90, this is 90. I got two right angle triangles. Their corresponding parts are equal. So, let me make this assumption. Let me make an assumption that this angle is D, then this angle is also D. A, B, C, D. Okay, there are four different angles. So my objective is I have to prove that this angle DOC, let me assume that the center is O. Angle DOC, understood? Angle DOC plus angle AOB will be 180 degree. Clear? The angles subtended by the opposite sides are supplementary. So let me do one thing. Let me add all these angles. Clear? I am going to add all these angles. Let us see what happens. I am going to add all the angles. All the angles, what happens? A plus B, A plus B plus B plus C plus C plus D plus A plus D. Clear? If you add all these angles, what happens? One complete revolution is over. So the total, sum of all these angles will be 360 degree. You know, 360 degree. Clear? If you take one complete revolution, that angle is considered as 360 degree. So I am adding all the angles, hence we get a one complete revolutions. So the sum of all these angles will be 360 degree. That is what I have written here. A plus B plus B plus C plus C plus D plus D plus A. The sum of all these angles equal to 360 degree. And now you can see that in this expression A is repeated twice. A plus A. Can you see that? A plus A. I can write it as 2A. The same way, each letter repeated twice. B plus B is there. It is 2B. C plus C becomes 2C, and D plus D becomes 2D. It is equal to 360 degree. Let me divide left side and right side by 2. Left side and right side divided by 2. Here in the left side, each terms are divided by 2. 2a by 2 will be a, 2a by 2 will be a, 2b by 2b, 2c by 2c, 2d by 2d. The right side 360 by 2 will be 180 degree. Clear? In the next step, a plus b, let me write a plus b in a single bracket, c plus d another bracket is equal to 180 degree. Clear? A and b grouped together, c and d are also grouped together. Look at that picture. What is a plus b? Look at this picture. A plus b is actually DOC. Clear? A plus b will be, look at this picture, DOC. Angle DOC plus. What is C plus D? Look at this picture. C plus D. C plus D will be angle AOB. C plus D will be angle AOB. Angle AOB is equal to 180 degree. What is the meaning of this equation? Look at this picture. DOC is the angle subtended by the side DC at the center. Is that okay? DOC is the angle subtended by the side DC at the center. And what about AOB? AOB is the angle subtended by the side AB at the center. AOB. So, the sum of the angles subtended by the opposite sides equal to 180 degree. You know that AB and CD are the opposite sides of the quadrilateral. So, sum of the angles subtended by the opposite sides at the center is 180 degree. In the same way, the first equation, this equation a plus b plus c plus d, right? Clear? Let me change the order of the sum. A and d written together. I can change the order, right? Clear? Let it be equation number 1. 1 can also be written as. I can change the order of the addition. A and D are grouped together. A plus D plus. B and C grouped together. B plus C is also 180 degree. Clear? I change the order of the sum. And again, look at this picture. A plus D. Carefully look at this picture. A plus D. A plus D, can you see? A plus D is angle AOD. Understood? Look at this picture. A plus D. A plus D will be angle AOB. AOD. Angle AOD plus B plus C. B plus C is which angle? B plus C. B plus C is angle BOC. Correct? B plus C is angle BOC. Angle BOC is equal to 180 degree. Clear? Understood? So AOD, what is this AOD? AOD. AOD is the angle subtended by the side AD. BOC is the angle subtended by the side BC. So sum of the angle subtended by the side AD and BC also 180 degree. You can give some name for this equation. Let it be say 2, let it be 3. So finally you can conclude like this from 2 and 3. From 2 and 3 you just write this statement again. the opposite sides of the quadrilateral, you can write it. Okay, just copy the statement. From 2 and 3, we can conclude that the opposite sides of a quadrilateral circumscribing a circle subtend supplementary angle at the center of the circle. You can write that statement here. Okay, this is the proof.